My name is James Vanderpool. I'm the Foundry Operations Manager here at the Metal Museum. And along with being project lead alongside our shop foreman, Jim Masterson, for the dinosaur project, I also took care of coordinating all of the cast elements for our 25-foot Mosasaur. So this project started out with a request from the Pink Palace here in Memphis, Tennessee, which is a museum that highlights, among other things, the natural history of the area. In their archive, they have a lot of fossil records of different dinosaurs. One of the fossil records that they have on hand is that of a Mosasaur. And so they approached the museum to create a sculpture that could be placed at their entrance gates. And so as they approached us, we looked at the entrance area where the sculpture would go, looked at the general form of a Mosasaur, the way it would move, the way it would twist and turn, and can determine with their area that a 25-foot dinosaur would fit it nicely without overpowering that area. And so me and Jim Masterson, the shop foreman, went and found ourselves a very detailed skeleton of a Mosasaur that we could put into a three-dimensional program. Once we had that three-dimensional program of a Mosasaur, we were able to go in, zoom around, fly through it, and more importantly, scale this dinosaur to that 25-foot mark we were shooting for.
My name is Jacob Brown. I trained as a blacksmith here 10 years ago as an apprentice, and now I am the facilities manager at the Metal Museum. Probably the most fun part of working on the dinosaur was maybe forging the femurs for me. The most challenging component was welding the skull together. That was probably the hardest welding I've ever done in my life so far. It looks great, and the casting that the foundry did was phenomenal. So I'm pretty lucky to have such good casting to weld on.
Hello there. So my name is Reed. I'm the current blacksmithing apprentice here at the museum. This is very nearly the last project we'll be doing while I'm here, which has been very exciting. So I did probably about 70 to 80% of the forging of, maybe even more than that, of the pieces for the dinosaur, many of which we had done sort of preforms that we had cut out of sheet steel and then forged to exaggerate or change their dimensions. Rather than having to start from a plain bar. But a lot of it, like the ribs for example, or certain parts of the vertebrae as well, certain parts of the tail, we forged out of just regular plain bar stock. Probably, for me, one of the two most interesting things that we were working on that I got to do was make all of the ribs, in particular the chest ribs that close in the middle under the sternum, and then make the tube fingers for the four sort of paddle fin hands. So we cast the palms in aluminum because they were very complicated shapes and quite large, but then did all of the fingers out of actually tubes of steel rather than solid pieces. And tubing forges a little bit differently than solid material because it doesn't have that mass throughout it to change its shape. And it was interesting to start with, and then a really enjoyable sort of exercise in learning new forging techniques and approaches to how to move the material. All told, there's probably something like more than 400, probably a little bit less than 600 pieces that got either forged or assembled in some other way. And it was a really wonderful project, and I had a lot of fun.
We utilized a lot of different techniques when it came to the casting of the different Mosasaur skeletal parts. All in all, we had about 25 individually cast elements that came together to form the aluminum portion of the Mosasaur. The skull itself had 17 individually cast parts. We were limited by the amount of aluminum we could pour at one time, and also the size of a mold. I think our biggest mold for one individual part weighed upwards of 500 pounds. But for the skull specifically, we knew that there was a lot of detail and it would take a lot to sculpt. For some of the other bones, like the breastplates or the palms of the flippers, we sculpted all those by hand. So we took foam, carved it out in the shape of the bones that we wanted, but for the skull, it was such a massive undertaking. We found some friends in Cincinnati, Ohio. There's a company called 3DX that has a robotic milling arm that we could input our skull into. And so they were able to start off with a giant block of foam and take care of about 85 to 90% of the carving of that skull and roughing it out for us. So in the end, what they sent us was about 4 different sections of the skull, the bottom jaws, and then the top was split into 2, so that we could start with a really exact representation of that skull and refine it by sculpting some of the interior areas that the robot couldn't quite reach. There was one instance, though, that they weren't able to help us out with, and that was the teeth. Dinosaurs have a lot of teeth. This one specifically had about 80. So if you try and carve something very fine in foam, it breaks and snaps on you. So as a solution for that, the museum was able to incise out all of the dinosaur's teeth and 3D print them. Once we got the foam carving, we were then able to inset 3D printed teeth into that skull, so we have a durable plastic tooth into that foam skull, and then we were able to take a mold off of that so that when we cast it in aluminum, the teeth and the skull were all one piece.
Hello, my name is Stacy and I'm a volunteer here at the Metal Museum. I'm helping make a pattern for the dinosaur that we're creating for the Pink Palace. Right now I'm working on inserting teeth into the bottom jaw. So we have a foam replica. You can see inside the green foam. And on the outside it's coated to give it bone texture and strength. And we have 3D printed these teeth individually. And I am fitting them, carving holes for them to fit snugly inside the bottom jaw. friends, it's Stacy again. Once we have our patterns made, we need to make molds of them. So for our dinosaur, we used resin sand molds, which is sand that's mixed with a high temperature glue so it will hold its shape and also hold up to the molten metal. The metal we chose to pour into our sand molds is aluminum. We needed it to be lightweight because the skull was so big and the rest of the body is made of steel. So we wanted the skull to be lighter. My favorite part of this project was spending time with the patterns, and as a mold maker you get to really focus and meditate on the shape of something and all its curves and edges, and I thought that was really awesome.
So along with 3D printing the teeth of the dinosaur, having this model and having a 3D printer helps us out in a couple of different ways that we didn't expect in the beginning. Portions of the skeleton that were forged, say the individual vertebrae or the hip bones, things like that, that the smithy was going to have to forge out and form, we're able to print reference models for them, so that they could have a finished item in their hand of the vertebrae they were working on, whether it was to take measurements off of, but as artists, we're tactile observers. So if we can hold something, touch something, and move something in the three-dimensional world in front of us, we can replicate it a lot easier.
I'm Jeannie Tomlinson-Saltmarsh. I'm the metal shop coordinator for the Metal Museum, as well as the foundry technician. During normal operations, the timeline for this project would have been much longer because we would have been doing a lot more public engagement, classes, workshops, professional development in conferences, and all that kind of stuff. So this was a pretty special time for us because all of our artists got to come in and focus solely on this project. And that's all we thought about for 6-8 weeks, and we all worked together, problem solved, and had a great time doing it.